Hello, this is Mr. Collier, and today we're completing the square to solve quadratic equations. Okay, let's complete the square for each expression. So it basically means like if you got a binomial like x plus 2, for instance, squared, you get x squared plus 4x plus 4, for instance, right? So this number comes from this number squared, and this number here is, well, double that number right there, right? So we're using that fact to complete the square. So the way it works is we're going to be adding on a number that's half of this number squared. Okay, the number in front of x, the coefficient of x, we're going to take half of that and square it. So half of 2 squared is 1. And now we get something that we can write as, sorry, by the way, we can't just add 1, that would be mathematically equivalent, so we have to do an add 1 and minus 1, then that's the same as x squared plus 2x, right? But just this part right here, okay, that can factorize to a perfect square. That's why it's called completing the square. This is the same as x plus 1 squared, and then we got a minus 1, okay? So there's numerous applications for this. We can use this to help us solve equations and help us graph them and stuff. So that's how it works. So like for this one, half of 10 is 5. So, oh, sorry. So we have to add 5 and subtract 5 to counteract it. And then that's just x plus, sorry, we have to add 25. We have to add half of that squared. Sorry about that. So that's 8 plus 5 squared minus 25, right? Here we'll get a fraction. Half of 5 is 5 over 2. So 5 over 2 squared is 25 over 4. So we'll add that and subtract it. This thing in the middle becomes b plus 5 over 2 squared. And then we got a minus 25 over 4 here, right? So they all pretty much work the same on this page. We can use that to help us solve equations. Let's look at the second one here first. First, we're solving equations, so we might as well divide it in by 2 first. That will make these nice and easier numbers, right? Then we can, half of 6 is 3. 3 squared is 9, so we'll add 9 and subtract 9. Okay, and then these first 3 terms here become x plus 3 squared. Then we get a minus 13 equals 0. X plus 3 squared equals 13. So x plus 3 equals positive negative root 13. So x equals negative 3 plus or minus root 13. So those are our 2 solutions right there. Okay, they're all pretty much the same. Sometimes you have to get 0 on one side. Actually, let's do this one right here. This one might be a little bit different. 2y squared minus 5y minus 5 equals 0. We need just y here for this to work. So we can divide everything by 2 or factor it out. So let's divide by 2. And we get this. And now we have half of 5 over 2 is 5 over 4. 5 over 4 squared is 25 over 16. So then we get a minus 25 over 16, then we get a minus 5 over 2 equals 0. So it's not going to be pleasant. There's lots of fractions in this one. Okay, this is going to, well, completing the square, we get y minus 5 over 4 squared is all this here. And let's bring it to the other side. They'll be positive and get a common denominator. So we'll have 25 out of 16 plus 40 out of 16. So y minus 5 over 4 equals positive negative root. That's 65 over 16. So that's 5 over 4. If I bring 5 over 4 to the other side, I can square root 16. That's 4. So I can write it as root 65 up here. And so we can even write it as one giant fraction because they have the same denominator, right? That'll always be the case. You can always get a common denominator and just add them together. So I wrote 16 there. That's 65. So here, same thing, but you got a root here. So let's do this on the side or down here. Let's do it on the side. So half of that squared. So half of that is going to be 3 root 5. And then square it equals 9 times 5 is 45. So we got w squared minus 6w root 5 plus 45 minus 45 plus 40 equals 0. All this factorizes to w minus half that, 3 root 5 squared minus 5 equals 0. W minus 3 root 5 equals 5. This is all still squared. So w minus 3 root 5 equals positive negative 5, root 5, I mean. So w equals 3 root 5 plus or minus root 5.